All right, so last time we finished up talking about how there's high and low pressure in the atmosphere, which kind of helps determine our weather. So let's just talk about that for a little bit. So we know the atmosphere is made out of gas. So there's gas particles everywhere. There's gas particles in front of you, behind you, everywhere. Even though you can't see it, it's still there, right? If you swish your hand around, you can feel some wind. Those are gas molecules essentially hitting you, colliding with you. So there's gas everywhere, even though you can't see it. In the case of our atmosphere, we're approximately 78% nitrogen and then 21% oxygen. So oxygen you breathe, nitrogen you also breathe, but you don't really use nitrogen. And then the rest is made out of other stuff. There's an increasing percentage of carbon dioxide, so you can take a look at that on your own. And so let's think about what this gas does, right? We said gases exert pressure, so the gases in our atmosphere also exert pressure. So when you're this is you just, kind of standing here, there's a whole column of gas right above you, right? All of this gas is right above you, and all of it is kind of pushing down on you. It's exerting pressure on you. And so what we call this is atmospheric pressure. Atmospheric pressure, right? And so atmospheric pressure depends on a number of factors. One of the most important is altitude. So if you're kind of down near sea level, you'll have one atmospheric pressure, so much gas pushing up on you. But if you're, say, up top a really big mountain, right, obviously not to scale. So that's you up on top of the mountain. You can think now you're going to have a smaller column of gas pushing down on you, and so there'll be less atmospheric pressure. So there's always pressure being exerted on you if you live on the earth, which you do. So as you can see on this kind of cartoonish picture on the right here, same thing we're talking about. There's always all of this gas kind of pushing down on you. And this pressure is actually pretty significant. So it's approximately 14.7 pounds of pressure per square inch. So that's like putting, about a 14, 15 pound bowling ball on the tip of your thumb. So it's actually quite a bit of pressure. The reason you don't feel like it's a lot of pressure is because you kind of evolved in this atmosphere, and so your body's meant to contain it, right? But there is actually a significant amount of pressure pushing down on us. And so you can think about, what happens when you go to space in like a, rocket ship, and what's the pressure inside that rocket ship versus outside, and et cetera, right? So let's go back to our conversation, right? We said pressure is a force over an area, right? Same thing that you see pictured with this bowling ball, right? It's that bowling ball is pushing down on the area that is your thumb. So we can talk about it like qualitatively, high pressure to low pressure, but we want to get more specific for that. So we want to talk in terms of units. So units of pressure. The SI unit of pressure is the Pascal. It gets a PA. And it's equal to 1 Newton over a meter squared. So this right up here is a Newton. It's the SI unit for force, and it's equal to 1 kilogram meter over second squared. And then this is obviously the area. In this case, it's meters squared. So Pascal actually isn't used all that much. In the US, we definitely don't use it. Most likely the unit of pressure that you're most likely familiar with is going to be the PSI, right? When you're inflating your tires, you have to set it to a certain PSI. PSI stands for pounds per square inch. So LB is the symbol for pound. Why? That's a good question. And per, remember, per always means divided by, so inch squared. Right, so pounds per square inch. So you can see it's a force over an area. In science, we don't really use PSI, so we're not going to use it in this class. Let's talk about the most common units used. So most common units in class, and the most common is going to be the atmospheres. or an atmosphere of pressure, and it gets the symbol ATM. And it's really simple to memorize. It's just the air pressure at sea level. Right, so the air pressure at sea level is about 1 atmosphere. So when you're talking about 2-3 atmospheres, you can think about it as kind of 2-3 atmospheres pushing down on you, or less atmospheres, less than. The next most commonly used unit is the torr. And so it's basically 760 torr equals 1 atmosphere, right? So I do want you to kind of memorize this conversion here. And this is exact. So both sides have infinite amount of sig figs. So torr is just another unit of pressure that you're going to see often. And then the last pressure or unit of pressure that you're going to see often is the millimeters of mercury. And we'll see later on why it's millimeters of mercury, but basically it's an instrument that's used called a barometer. And this is pretty easy to know too. It's 1 millimeter of mercury is approximately equal to 1 torr. So basically millimeters of mercury and torr are essentially the same thing for our purposes. So I want you kind of just to know all of this, no atmospheres, no torrs, no millimeters of mercury, and know that 1 atmosphere is, you know, the pressure at sea level. So now that's just some kind of extraneous information just to give you some points of reference. It's approximately 14.7 psi is equal to 1 atmosphere. And then in terms of kilopascals to atmosphere, it's approximately 101 kilopascals is equal to 1 atmosphere. So those are just for reference, but everything in the green circle you want to know well. Just another point of reference, just think about here in Menifee. I can spell Menifee. You have a pressure of approximately 1 atmosphere, so we're about sea level. So we have a pressure of approximately 1 atmosphere. If you go somewhere really high up, something maybe like Denver, right? Denver, Colorado, mile high, it's about 0.8 atmosphere. So you can see as you go up in altitude, the atmosphere decreases. Another point of reference, Mount Everest. That atmospheric pressure is only 0.33 atmospheres. So much less there. All right, so we know these pressures in atmospheres, but of course we need to be able to convert units. What if somebody's talking about torr? We want to know what they're talking about. So let's take a look at converting 0.8 atmospheres to torrs. So this is a pretty simple unit conversion, right? You have, here's what we have. We know we have 0.8 atmospheres. And then we also know the conversion unit. This 760 torr is equal to 1 atmosphere. So let's go ahead and convert. Generally, you want to start with the thing that's not a conversion unit. So that's the 0.8 atmospheres. And then you want to use the thing that is a conversion unit that has atmospheres somewhere. So atmospheres there, atmospheres there. Since this atmospheres is on the top, the next one goes on the bottom. There's a 1 in front of it, and then up top goes 760 torr. And so now the atmospheres cancel out. And then you just plug in your calculator 0.8 times 760, and you get 600 torr as your final answer. So you want to be able to do this really quickly and simply. It's not a hard conversion. Final question we want to think about is how are we measuring this pressure, right? What does the 760 mean? What does that mean? Well, we use a barometer, right? And so basically it's this thing filled with mercury and then a vacuum above it. So the atmosphere is pushing down on this mercury, and so it's causing the mercury to climb up. And the more pressure you have, the higher up it goes. And so you can calibrate it. So you can read this distance here, which is your millimeters of mercury, to determine the pressure. Why do we use mercury? Well, we use mercury because it's really dense and it's really heavy. So it takes a lot to push it up. So you can see this right here is only 760 millimeters. So that's approximately 1 atmosphere. It's only about 2.5 feet. So that's a good sized column that can fit in a lab. What if we used water instead? Well, water is a lot less heavy, a lot less dense. And so you can see here for the same atmospheric pressure for 1 atmosphere, we'd have to have a column that's about 40 feet long, which is that's not going to fit in a lab, so it's just not practical. So the reason we use mercury is for kind of a practical sake.